Hello again. In the previous lesson, we introduced polynomial functions. We identified things like degree, leading coefficient, constant, and behavior, zeros, multiplicity. So in this lesson, we'll use those zeros and multiplicities to understand the shape of those graphs. But let's begin with quick rules. Zeros, as shown here, are x values where f of x is equal to 0. Odd multiplicities occur usually, or excuse me, odd multiplicities usually cross the x-axis, okay? Even multiplicities usually touch and turn around. In behavior comes from the degree and the leading coefficient. So the main idea is this: the factoring form of a polynomial tells us where the graph meets the x and how the graph behaves at each zero. Okay, so that's very, very important. So first of all, let's read example one. It says sketch from factored form. So sketch the key behavior of f of x equals x plus 3, x minus 2, x minus 1 squared, x minus 4, and identify those things. Start with the zeros. Okay, so zeros occur when each factor equals 0, right? So when each factor equals 0, remember we set these equal to 0, so we know for a fact that we have x plus 3 equaling 0 is going to become x equals negative 3. We also have x minus 1 equaling 0. We know that's going to be x equals 1. Then we have x minus 4 equaling 0. We know that's going to tend to x is equal to positive 4. Now, identify the multiplicities. So the multiplicities in this expression, we see we're going to have an exponent of 1 here. We have an exponent of 2 here. And we also have an exponent of 1 here. So the factor x plus 3 has an exponent of 1. The factor of x minus 1 has an exponent of 2. The factor of x minus 4 has an exponent of 1. So the multiplicity and I'm not going to write that several times, the multiplicity of 1 and of 1. Okay. Now determine whether the graph crosses or touches. So again, odd multiplicities mean they cross, even mean they touch and turn. Okay. So we know that according to that information, that we have x minus 3, that's going to cross. We have x equals 1, that's going to touch. And then we have x equals 4, which means it's going to cross as well. Now, determine the end behavior, okay? The end behavior of these particular things. So the degree is the total of the multiplicities, right? So the degree is the total of the multiplicities. So we have a multiplicity of 1 plus a multiplicity of 2 plus a multiplicity of 1, which tells us that the degree of this expression, if we were to factor it, the highest exponent would be 4. So the leading coefficient is positive because the leading term comes from x times x times, or excuse me, x times x squared times x, which equals x to the power of 4. Okay, so we know this if we were to do x times x squared, then multiply that by x as well. So this is an even degree polynomial with a positive leading coefficient. Both ends are up. So that essentially says that as x tends to negative infinity, we have an f of x that's going to tend up. Then as x tends to positive infinity, we have an f of x that's going to tend as well. All right. So the end behavior is the left side is up and the right side is also up. Okay. So the graph starts on the left, crosses at x equal -3, touches and turns at x is equal to 1, then crosses again at x is equal to 4, and the ends up on the right. Okay, that's essentially how we interpret that information. Okay, example number 2. A polynomial graph crosses the x-axis at x is equal to -2 and x is equal to 3, and then touches the x-axis at x equals 1. List possible multiplicities and write a possible factored form. Crossing the x-axis means odd multiplicities. Touching the x-axis means even multiplicities. So the graph crosses at -2. So the simple multiplicity is 1. The graph touches, as a matter of fact, let me write. So crosses at x is equal to -2. Touches at x is 1. Then crosses at x is equal to 3. So the simplest possible multiplicity is would be 1, 2, and 1. Okay. So multiplicity of 1, multiplicity of 2, multiplicity of 1. Now, if x is equal to -2, if if x is equal to -2 is a 0, then the factor is x plus 2. If x is equal to 1, then the factor is x minus 1. If, let's see, so in this case, let me see, and that's again, since it touches there, we're going to use an exponent of 2 since it touches here, right? We're going to use an exponent of 2. And then since it crosses, and then we have an exponent of 3 at 0, the factor would be x minus 3. So essentially what this would look like is f of x equals x plus 2, the power of 1, x minus 1 with the power of 2, and x minus 3. Okay, very simple. So this is one possible polynomial. There are other possibilities if we use higher odds or even multiplicities or even a different leading coefficient. But this is like the least degree version with a leading coefficient. Right? All right, pause and try the problem at the bottom. Okay, so for px equals -x or -2 parentheses x plus 1 cubed parentheses x minus 2 squared, we're going to identify what we see here. So first of all, let's start with the zeros. So we have a 0 of -1 and a 0 of 2. So we have x equals -1 and x is, so those are the zeros. Okay, so we have our zeros. The multiplicities, we have a multiplicity of 3 and a multiplicity of 2. Okay, so multiplicity of 3 in this case and a multiplicity of 2 in the case for this one. So at x is equal to -1, right? Is x is equal to -1, the multiplicity is 3. And so that is an odd, or that is odd. So the graph is going to cross the x. Okay. Since the multiplicity is greater than 1, the graph is going to flatten. Okay. Or I should say may flatten. we don't know, we're not going to catch it. Then x is equal to -1 crosses with flattening. Okay. So at x is equal to 2, the multiplier is 2. And so that is even. So the graph touches and turns around. Okay. So this graph, in fact, this actually goes, this actually goes together. Minor mistake. So again, uh, this, it crosses the x-axis, it may flatten, it crosses. And so again, um, x is equal to -1 is going to cross with flattening. Okay. And then at x is equal to 2, we have a multiplicity of 2. So again, that's even. So that's even. So the graph is going to touch and turn around. So when you have x is equal to 2, just know that it's going to touch. Now, it says also determine in behavior. So the degree is 3 plus 2, 5. And the leading coefficient is going to be -2 in this case. So this is an odd degree polynomial with a negative leading coefficient. So as as x tends toward negative infinity, you're going to get positive infinity. As x tends towards positive infinity, you're going to get negative infinity. So the left is up and the right is down. Okay, let's continue. Example number 3. Example number 3 says find a polynomial from graph features. Write a polynomial with zeros -4, 0, 3. The graph touches at -4, crosses at 0, crosses at 3, and has positive leading coefficients. So a 0 gives us a factor, right? So since 0 is -4, that factor is x plus 4. So just to list the zeros, we have a 0 of 4, 0, and 3. That -4 tells us we have x plus 4, right? So the -4 is going to touch, right? The -4 is going to touch. X equals -4 touches. Again, that's x plus 4 squared, okay? Because essentially what we're looking at is the 0 gives us a factor, and that -4 is the 0. So the factor is going to be x plus 4. And since the graph touches at here at -4 being 0, we're going to use an even multiplicity. Remember, because anytime it crosses, it must be an even multiplicity. So the smallest even multiplicity is a 2, right? Because 1 would be odd, and then 0 is non-existent. So the smallest even multiplicity is 2. So x equal -4 touches, and that would be x plus 4 squared. Since 0 is, since x is also a 0, right? The factor is simply x, okay? So the factor is simply x, and the same goes for this before. So that's what the factor will look like. This will be what the factor would look like. So the graph crosses at 0. So what we're gonna do is we're gonna use an odd multiplicity. Smallest odd multiplicity is 1. So x equals 0, that crosses, and we're going to have a factor of x. Now, we have the final one, which is 3. So the graph crosses at 3. So we're going to use a a multiplier of 1. So that multiplier, x is equal to 3, is going to be x minus 3. We have x 3 going to cross, going to be x minus 3, and a multiplier of. So the leading coefficient must be positive. So obviously the easiest choice is to use 1. We're going to have f of x equals x parentheses x plus 4 squared parentheses x minus 3. So, and again, this is a possible polynomial from the required graph behavior. It's possible, but there are others that you could use as well. All right, let's continue. Example number 4. The graph has 4 turning points and both ends go up. What is the least possible degree, and what can you say about the leading coefficient? So a polynomial of degree n can have at most n minus 1 turning points. So this graph has 4 turning points, right? Graph has 4 turning points. Very important. So the degree must be at least 5. So n minus 1 greater than or equal to 4. So n is greater than or equal to 5. Now, it says, and both ends go up. So, but both ends go up, that means that the degree must be even. So the smallest even degree that is at least 5 is 6. So the degree possibility is 6. That's the least possible degree. So both ends are going to go up. That also means that the leading coefficient is positive. So the least possible degree is 6. Leading coefficient must be positive. All right, a common mistake. A student says the zeros are the places where the graph crosses the y-axis. Correct the statement. So that statement is incorrect. Zeros are x values where the function equals 0. Okay, where it crosses essentially the x-axis. Okay, so again, that means that 0 occurs where the graph meets the x, not the y. So the way we look at it is we have zeros are a function of f of x equaling 0. So zeros occur at x-intercepts. Okay, the y-intercept is different. The y-intercept occurs where x is equal to 0. So uh, that's just that's something that we learned early on. So the correct statement is zeros are the x value where the y crosses, such as the. Okay. Final review. So zeros are x values, not y values. And those x values are where the function is equal to 0. Odd multiplicities mean that the graph is going to cross. Even multiplicity means that the graph touches and turns around. The degree controls the possible turning points, and end behavior depends on degree. and the leading coefficient. And it's also very important that the factored form is powerful because it shows the zeros, the multiplicities, and the graph behavior directly. All right, and that concludes this video. Again, thank you for watching.